Good afternoon. Welcome to the Light Building here in Farmington, Connecticut. My name is Franzi and I'm the product manager for TruBend. And I welcome you to our TruBend presentation of this digital intech here. We're going to talk about the entire bending process chain and how we can reduce the non-productive times and how you can bend more efficiently. So let's take a look at the different items that we're going to take a look at here today. All right, so if we think about non-productive times during the bending process, it starts all the way from programming. So how do I get started when I have my part file? How do I get a bending program? That's step number one, and we'll take a look at that. Actually, one of my applications engineers, Anurag, he will show you how to prepare a bending program efficiently and quickly. The next step would be setup optimization. So how do we optimize the tooling that we use in our bending process further down the road? So when we program, already consider what we're going to do in the actual bending process when that happens. Then the next step, we're going to take a look at two machines here in our showroom. So one will be the TruBend 7050. We're going to point out a couple of things that we can do better and quicker during setting up a bending job, and how we can optimize the productivity of that machine. We will also take a look at our TruBend 5000, actually our 5170, and we will also show you a couple of enhanced options on that. Then one big topic as well is the quality assurance. So how do I get from the first part to and maybe having to do a second part to having a first part that is a good part? So what are the options that we offer at TRUMPF to make sure the entire process chain here is as efficient as possible? And then at the end, we'll also see some bending happening here today. So we're not only going to talk, we're also going to show, and we will see one part on the 7050 and two parts on the 5170. And we're going to point out a couple of things that we can do and how we can help you to optimize your operation and how we can make this all more productive and reduce the non-productive times. So I would like to get started with the programming part here. Anurag is actually right now going to program a part for us and also show our tool setup optimizer. So let's take a look. Anurag, here you go.
Hello everyone. Today I'm going to show you TechZone Bend and how we use it to program for our TruBend machines. After we make some parts, I'll also show you guys the TSO, which is the Tool Setup Optimizer. So if you have multiple parts and you want to minimize the amount of tool setup time, then we can use the TSO. So first, let's get started. We'll go to File, Open, and we will select 8 different parts that we want to program today. So at the bottom, you can see the name of the part, the material type, and the material thickness. So first, what I'll do is I'll go into Workflow, and I'll fold this to 3D. So this is what my part will look like after it is bent. Next, I'll go into BendTech and I'll select a 5170 to program these parts. Here you can see I can have multiple different machines to program my parts with. Okay, I'll bend it, and you can see quickly the software has already generated a program. So you can see a certain back gauge strategy, you can also see a bending sequence, and if you want to change any of it, you can change this right here. So here what I'm making sure is I'm comfortable with this bending sequence and that this is going to work with my production environment. So here you can see this is a 6-bend program, and there are multiple things that the software is checking when it's programming a part. Okay, now that I'm satisfied with this program, what I can do is I can go into my workflow and I can say create a post-process bend part. So what this does is it creates an NC code for me to take to my machine and start bending the part. And you can see right here it took a matter of 120 milliseconds to make this part. So this is quite fast. Now what I'm going to do is I'm going to use the repeat button at the top right here, and I'll say process and bend all these other 7 parts for me. And you can see the software is going through the different parts, and it's going to highlight which parts need some more attention. So here you'll see that 2 parts require some attention because they're in yellow, but the parts that are gray are good to go, and we can start programming and bring it to the machine control right away. So next what I'll do is I'll save all these parts. Okay, and what I'm going to do now is I'm going to look at the trouble parts. So the parts that were yellow, let's take a look at them. Let's find them. So here's a part that was yellow. And you can see I can pull out some more messages and menus when I click the down arrow here. And you can see bends 1, 2, and 3 are the ones that are yellow. And the reason that they're yellow is because there are holes too close to the bend line. So here you can have some deformation around the holes. And you can see, okay, near this bend, there's a hole right there, which is bend 1. And you can see on bend 2, there are some holes very close to the bend line as well. So the software is just saying, hey, programmer, be aware that with the current tool setup, you might have some deformation along the different holes. So let's take a look. I can change my lower tool here. So from an EV007, I can use instead of a 30-degree die, let me use a 40-degree die. Okay, well that will make somewhat of a difference. Let me use a W20 die. Now we're going to over tonnage the tools, but you can see that we might not be able to deform the holes as much with this set of lower die. Okay, and the software will also tell you you're going to overload your punch by about 100%. So if we don't want to do that, we'll just go right back to the other lower tool. Okay, so that gives you an idea of the type of messages that the software will tell an operator or a programmer before the program is brought out to the machine. So next, what I'm going to show you guys is the tool setup optimizer. And this feature lets you minimize the amount of tool teardowns and setups that you have to do. So what we'll do is we'll go to File, New, and TSO Batch, and we'll add parts, all the open parts that we have, and we'll say, please optimize these parts. And you can see 8 parts were optimized in 0.1 seconds. And you can see there is setup number 1, and then in green we have setup number 2. So it looks like the software found 2 different tool setups that is required to make all these parts. So let's take a look. So this is setup number 1. And you can see this is setup number 2. So the software has found 2 setups that will make sure that we can bend all 8 of these parts. And that is a very nice feature, especially because this will reduce any unproductive times with your machine. So thank you so much for watching today. I hope you liked this presentation of TechZone Bend and TSO, the Tool Setup Optimizer, and happy bending.
Excellent. Thank you very much, Anurag, for showing us. And yeah, now that we know how we can optimize the programming and also the tool setup, let's take a look at the actual setup at the machine. So therefore, I would like to introduce you to Michael. He's one of my applications engineers and TruBend experts on the team. And he is standing here in front of our TruBend 7050. Just for you to understand, because sometimes the numbers are a little confusing, the first digit of our machine will always stand for the series of the machine. So in this case, it's a 7000 series. The next digits will describe the tonnage of the machine. In this case, we have a 50 here, which is 50 metric tons, so about 55 US tons. And that is how you can always pretty easily, I hope, understand how we use the TRUMPF nomenclature. So Michael, in front of the 7050, will show us a couple of things that we have as part of our machine to optimize the setup. One of the times, or the non-productive times, is that when our operators look for tooling. So they need to go to the tool room, they need to go to wherever you store your tools, and they will need to find the right tool. During that operation, they're not at the machine, your machine isn't running, and you're not making parts. So here on our 7000 series, we have a very innovative and cool solution, which is what we call the pull-out tool cabinet. So right next to the operator, we have 3 drawers where we can store both upper tools and lower dies in order to, have them close to the operator and make it as efficient as possible. So you just saw that Michael grabbed 2 tools that he was still missing for his next setup here, and he just put them into the machine. You can also see the LED light strip on top of the upper tools. So this will show the operator exactly where they need to put the tools, and so no more measuring or seeing exactly where the tools need to go. So a very nice feature. Then if Michael now, he just started the program, so the bend guards on the side came out. So that is our safety feature, which will monitor the pinch point of the machine. And so no manual interaction needed from the operator. They just go directly to where they need to be for this particular program. Now you can see that Michael is standing in front of the control, so he has it right in front of him. And we can also see the 3D graphics here. So Michael can pivot, he can zoom in and out. So since it's the first time that he's bending this part, he can see exactly which back edges to use, what the tool setup is, and if there's anything else that he wants to look at. He can pin a certain view, so every operator can kind of customize this to whatever he or she needs in that situation, and we can do that for every bend. Excellent. So now I would say let's bend some parts. So Michael, if you want to get started. Awesome. So in this case, we only have a part with 2 bends. And notice the I-axis shift here on the bottom. So we use the same tool setup for 2 different operations. So we had a pre-bend, and now we're doing a folding operation. And since this was so quick, Michael, if you could just do another one, that would be awesome. So again, pre-bend, notice the lower die bed. Now it is shifting back, and we can use the exact same tool setup for the folding operation. So that will also save the operator time. They don't need different tool setups. We can use the same tool setup for 2 different bending methods. So Michael, if you just want to show off that part. Excellent. Thank you very much. And now we will go over to our 5000 series to show you a couple more things that we can do when we set up the machine and in order to optimize that flow. So let's take a look. We will now see our tool master working, and the tool master will automatically set up the tooling for our machine. This is just a quick teaser. We'll take a look at the tool master in more depth when we go from the first part to the second part, but I also don't want to take up the camera here, so let's just take a quick look, and then again we'll explain more about the tool master when we switch from the first to the second part. You can see, however, already also the lights, the LED light strips that we already saw on the 7000. So of course here the tool master knows exactly where they need to go, but even if we had now an operator loading this, so if we weren't using tool master, they again know exactly where they need to put their tool setups. Also here, nice to see the upper tool that the tool master just brought in, or the shuttle just brought in, is reverse, and we'll take a look at that later, how that is actually working inside of the tool master with our rotating carousel. All right, so the tool setup is done, and before Anurag now starts bending the part, we want to take a look at our quality assurance. So what we said in the beginning, how can we make sure that the first part is a good part? And one of the options that we offer at TRUMPF is so-called ACB, so automatically controlled bending. And in the space of ACB, we have 2 different main areas, I would say. On the one side, we have the ACB hard tool, which we can see here. We have that both as a wired option in this case. We also have that as a wireless option. ACB hard tool works the following. We have 2 sensor discs here at the bottom, which will touch the inner radius of our part. And we are actually measuring the distance between the 2 sensor discs, or the centers of the 2 sensor discs, and that is how we calculate the angle. Excellent, thank you. And then actually all the way over here, we have our Acb Laser. I'm just gonna wait for the camera to come over. Acb Laser is the second ACB area or method that we have. So we have 2 measurement units, one in the front and one in the back of the machine. So you see them both here. Each unit is equipped with a camera and a laser. The way it works is that the laser projects a line on the part, and the camera will detect the position of that line and will, with that, calculate again the angle of our part. we have a lot of customers that have both ACB, either wireless or wired, and ACB laser on their machine. And that is because we think these two technologies don't necessarily compete with each other. They both have their space, and they both have their applications. It will really depend on what you're trying to achieve. ACB hard tools, for example, is excellent for very short flanges because the ACB laser will, depending on your die width, require a certain flange length in order to read that line that the laser is projecting. So short flanges would be a perfect application for hard tools. Also, very long tools, you can have multiple hard tool setups, and the ACB laser can do that as well, but it will take just a little bit longer to do that reading. The ACB laser, however, is very easy. It's you don't need setup. You don't need a lot of different tools. You can just use it with any tool that you have. And that makes it a very flexible option for fabricators that use or have a large variety of parts that have small batch sizes that do a lot of different tool setups during the day. ACB laser is an excellent solution. At the end of the day, both options will give you what you're looking for. You will have a very high accuracy, so plus minus 0.3 degrees. They're both fast options, and they can be used for a big variety of bending methods. So today we're actually going to use ACB laser on our tool that we're going to bend. And yeah, Anurag, take it away. You can go ahead and bend our first part here. So again, we see the LED light strips, and as Anurag is now starting the program, we again see the bend guard coming down, and also we see the ACB laser unit at the lower die bed going into position. So now Anurag will start bending, and perfect. And we can also see how he switches from one tool setup to the other, and the ACB laser working as well. So with the ACB laser, it's about 1 extra second that it takes for the measurement, but then we make sure that the angle is really perfect. So it will hit it twice. So first to test the spring back, and then to bring the part to the actual angle that we are requiring, or that we programmed. We can see here our 6-axis back gauge in the back. I think you just have the better view right now. And I have to say, this is a very challenging part, and it also has I would say, built-in quality mechanism, so we can see that right here. So we know this is a good part if these teeth that Anurag is showing off right now, if they fit perfectly into each other, which you can see they do on both sides. So we know that we have perfect angles here. And also on the other side, we see that these two sides are perfectly lining up. So there's no light between, there's no space between. So we know that both Anurag, the machine, and also ACB laser did a great job. Awesome. All right, so now let's take a look at the Toolmaster. So as we already teasered it, the Toolmaster is our automatic tool changer that we offer for our 5000 press brakes. Just as a reminder, the 5000 press brakes that's our flagship machine. Yeah, so it's our most flexible solution that we offer to our customers in the bending space, and this is also where we offer the Toolmaster as an add-on option. So Anurag is now starting the Toolmaster, and you see the machine moves up to line up perfectly with the rails of the Toolmaster. Our bend guards go up, and the bridges of the Toolmaster close the gap to the machine. And here we see our shuttles picking up the tools. We approximately calculate 10 to 12 seconds per tool, so this is extremely fast. And they also work simultaneously on the top and on the bottom. If we now, so the tool shuttles will grab the tools and they will put it on a rotating carousel in the Toolmaster. So maybe let's switch the camera view into the Toolmaster. And Yes, so the shuttles will take the tools, we'll bring them into the toolmaster, and then we have a rotating table. This is important because as we saw in the first tool setup, we can use the tools both ways. And so the toolmaster will automatically rotate the parts as we need them for the program. So after the tool shuttles pick up the tools, put them on the carousel, there are two manipulators at the back that will pick up the tools and store them where we need them. They will also, for the next bending operation, pick up the new parts, the new tools, excuse me, that we need. And yeah, now we already see that the next setup is done. The maximum part size, tool size, excuse me, is a 500 tool. So this is what you're using here, and that is another option how you can optimize your non-productive times, because of course, when the toolmaster needs to grab less tools, then that makes the process more efficient. So we're now showing off another nice feature of the 5000, which is our so-called bending aid. So if we think about the non-productive times during machine operation, it could be that Anurag has a very heavy part like he has it right now. Normally, he would then get Michael from the 7000 machine over to help him. And during that time, of course, Michael would be happy to help, but his 7000 press brake would not be making parts and it would sit idle. Therefore, we have the bending aid that can help with large and heavy parts and kind of replace that second operator that you normally need. So Anurag is bending a tool here. You see a part here. You see it's a large, heavy part, and he is actually also using roll bend tooling on the lower die bed here. That is another nice feature to to reduce your non-productive times, because that is suited for when you have holes very close to the bend line. So we will make sure that there are no deformations, and therefore, again, first part, good part. During this part, Anurag is using the learn function of Acb Laser. So while in the first part that we bend, Acb Laser measured every single time, we're now measuring the first time, and whatever the machine learns from that spring back and that correction that it makes, it will apply it to the rest of the part as well. So we only need that 1 extra second for the first bend, and then the subsequent bends will be even faster. And you can see the bending aid going up and down. The bending aid can support parts of up to 220 pounds, so it's very heavy duty, and it can go up to an angle of 30 degrees. And there you see the holes that we supported with the roll bend die. Very nice. Awesome. So let's sum it all up, all the non-productive times that we can reduce. Let's take a look at the different things that we kind of went through here. So we started with the programming of the part, right? So how can we make programming more efficiently? And also, I think the tool setup optimizer, I hope that it was obvious through the demo that Anurag did on how we could reduce the different tool setups and how we could go from 8 tool setups to 2, right? So less setup means less times that your operator spent not bending a part. And then we took a look at a couple of different items here. So we started with, for example, the tool cabinet on the 7000, the automatic bend guard that helps us, the hydraulic clamping that will reduce your setup times. And then also, of course, the HMI that is very intuitive, very easy to learn, and it's very quick for the operator to see what the next operation is going to be. On the automation side, we took a look at the toolmaster, which will also help you with the setup of your part, and then again, the LED light strips are just a nice feature. And even if you have different tool setups or different stations, let's say, they will light up so that the operator can see which setup to use in the next bend. So there's no second guessing which tool setup do I need to go to now for bend number 10. You will know exactly where you need to go. And then, yeah, the quality assurance, ACB is definitely one of our main answers to that, both the hard tool and the ACB Laser. And remember, they both have their space, so it's not necessarily that one is better than the other. It really depends on what you're trying to do. And also for us as TRUMPF, it is very important for us to understand what you're trying to achieve with your operation and what your applications are, how many setups you have, and so forth. And then finally, when we operate the press brake, we have certain functions that help us with that. So, for example, we have the bending aid. We can also start and adjust the program with Mobile Control and Mobile Control Pro on our rail right above the upper tools. And yeah, so all in all, I hope that we were able to show you what the different options are that we see, how we can optimize the productivity for the standalone press brakes that we have. So I would take a look at a couple of questions. I actually should have grabbed my iPad here right before I went onto camera, so but I'm back. So let's take a look what we got. All right, so we have a few different ones. I'll just pick a couple. First question, what is the difference between, this was the last one that just came in, what is the difference between Mobile Control and Mobile Control Pro? Of course, I mentioned it during my summary, but we didn't explain it as we presented. So Mobile Control and Mobile Control Pro, we will see over here. I hope we can zoom in maybe a little bit. So here we have our Mobile Control and also the Mobile Control Pro. So with the Mobile Control, you have a couple of key functions, or the operator has a couple of key functions right here where they bend. So no need to go over to the control, especially when you have a long press brake or you have multiple setups. You have everything right here that you need. So you can, for example, activate or deactivate the hydraulic clamping. You can change the light setting right here. You can operate your bending aids. We can have up to 2. You can change the bending aid speeds. And also you can start or stop a program. The Mobile Control Pro on the other side is over here. And there we have the same options, but we have a couple of enhanced functions, I would say. So here we can really make some adjustments right where the operator is. So for example, you see here bending step number 1. So we can go in there and then have, I think, 14 different parameters that we can manipulate here. So for example, we could go in and manually change the press force. And you see it it's very easy with this little wheel that we have. And we could make some adjustments to all the different bending steps. If we now go back here and we just say, okay, maybe bend number 3 or bend number 2, Anorak wants to hit once again, we could just select that. So let's say bend number 2, we'll hit play, and our machine will then also go right into the position where we need it to be. The Mobile Control and also the Mobile Control Pro can be picked up. So let's say we have different setups over here. So we have one over here, one over there. The operator could just take it and put it wherever they need it. And we could also have multiple of these on the machine. So depending, again, what your application and what your operation looks like, these are really nice functions to, again, increase the productivity and make it easier for the operator. All right, we have a couple of minutes left, so I would just grab a few more questions here. Can I put old TRUMPF tooling into the Toolmaster? That's an easy answer. Yes, you can. So it would always, it would depend if you have custom tools and they have some kind of extraordinary geometry. We would just need to look at that, but I would say yes, with very few exceptions. What about automation, TruBend Cell? Yeah, well, good question. This is definitely then the next step up. So today we wanted to focus on what we can do on the standalone press brakes and how we can increase the productivity on those. But not to, shameless plug, but we will have some webinars on our new TruBend Cell 5000. They are planned for April, and because we, as TRUMPF, we just introduced our new TruBend Cell 5000, and we actually just installed it here in Farmington as well with the Bendmaster 150. So we will be ready for some demos here soon, and then we'll also have some webinars where we go into a little bit more depth. So as long as you're subscribed to our email list or social media channels, you'll see that, and then of course we would love to see you there. And then what's the angle measuring range for Acb Laser? Acb Laser generally can go from 45 to 145 degrees. So that would be the measuring range. So it's well suited for large radius, for example. Yeah, so I think we're 12:29, so we should be just on the minute. Yeah, everyone, thank you for dialing in. I would just welcome Anurag and Michael back here. So if you have any further questions that we can answer, feel free to use the chat. I will be online later on. So will be Andrew Jeffrey, who's a sales engineer on my team, and also feel free to reach out to our entire sales force. So yeah, from all of us here in Farmington, thank you for dialing in, and hopefully you'll have an interesting rest of your day and enjoy the other presentations.